So picking up where we left off from yesterday. Okay, yesterday we were talking about the different types of transformations that happen to a sine or cosine graph. Okay, they're the same types of transformations that we dealt with when we did quadratics, fractional functions, all of those, back from the very first unit. Okay, that's what you guys did at homework on. Today we're actually going to be graphing those different types of transformations with your original graphs of sine and cosine. Okay? So to start off, we're starting with your vertical stretches, which affect the amplitude of your function. Now the amplitude is half the distance between the maximum and minimum values of the function. Or you can think of it as half of the height of the wave. Okay, so if I were to take this maximum and this minimum, figure out the distance between them, and then divide by 2, I would have my amplitude. Or you can look at it as, okay, what is that line that's cutting my graph in half? What's that distance, okay? Either way, that represents amplitude, as you see here, okay? And where would that A come from? Have you guys seen an A before from like yesterday's notes? It's from the first part plus B. That's the general form. It's the very beginning of your function. Okay? A lot of y'all need to check your slam. I'm going to call y'all individually. So to graph, question?
Is that
Mm-hmm. Yep. Your amplitude is always positive, absolute value bars. Okay? Because remember, if we think of it as the number that's right out front, remember it could be negative or it could be positive. The negative, though, does not mean that your amplitude is negative. The negative means that
the graph, like the flip,
it's being flipped, it's being reflected over an axis, okay? So to graph a function that's in the form of a sine x or a cosine x, we're going to multiply all the y values of the function by a, whatever number it is, and we're going to keep the x's the same, okay? So the first one we're going to graph is one of the first ones we did the description on from yesterday's classwork, okay? Describe the transformation. What does this 1/4 do?
it's vertical.
Is it vertical? Shrink
By 1/4.
by a factor of 1/4. So to actually shrink this graph of sine, we're going to multiply all the y's by 1/4, okay? So to have it as a reference just a little bit, what were the points of the original sine graph? We graphed in our problem today. Where did it cross the y-axis? Do you guys remember?
0, 1.
It was at 0, 0. And then from 0, 0, it went up to, and what was the horizontal coordinate that went with it? Pi over 2. Then it went down to, it intersected at pi, and then it went
down to -1 and
3 pi over 2, and then it
started to go back up
to,
to 5.
okay? And it did the same thing over here. It went down, then up, now some more, then back down, okay? Sine is what type of a function? What type of symmetry does it have? Origin, so it's odd, okay? So all those points, 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. Those are the points of your original sine graph. So to graph 1/4 sine x, we're going to multiply all of your y's by 1/4, okay? So this 0, 0 is going to stay 0, 0 because 0 times 1/4 is 0. But this pi over 2, 1 is going to turn to pi over 2, 1/4. Pi 0 stays pi 0. 3 pi over 2, -1 turns into a -1/4 for its coordinate there. And then 2 pi over 0 stays. So these are the points that get graphed to show that vertical shrink. And make sure you guys are drawing smooth curves. And doesn't it look like I took the top and the bottom and just squished it? Doesn't it look like it flattened out?
Yeah.
Okay? this point, where's it gonna be at? Negative 1/4.
I was gonna say, do you want to do negative something?
Well, I was pausing so that y'all can catch up. We'll do this one together. Next one is gonna be on you. Alright? Where's this point gonna be? Stays. This point is gonna go to 1/4, and this point stays. And so if I were to continue this out, it looks like I basically took two wooden bars from the top and the bottom and just squished it together. It flattens out. It is a vertical shrink. Does everyone see it? Okay. And all we do to do that is multiply all of our y's by a. Okay? Because that's what happens when it's on the outside, it affects your y's. When it's on the inside, it affects your x's. Okay? The next one's on you. Next one's on you. I want you to graph -3 cosine x. Okay? If you need a reference point, look at your problem of the day. Remember, we graphed cosine, the original graph of cosine already. If you need the points as a reference. And then I want you to graph -3 cosine x. So for this problem, describe the transformations.
Flip
over
over
the
the
x.
Flip over the x-axis and
Vertical stretch.
vertical stretch by 3. So that means that this point now is going to be down here somewhere, and on top of that, this graph is going to basically be pulled from the top and the bottom. So we're going to multiply all of our y's by a -3. So this becomes a this,
0,
this one,
3,
and this one,
0,
and this one.
-3.
So when I plot these, this point is now down here. This point stays where it is. Back up to the top, stays where it is. Come down to the bottom.
Looks like DNA.
Yeah, found a double helix. What about this point? Stays. But this point goes to a +3. This point and this point goes to a -3. And there you go. Questions? Now for your horizontal stretches, they affect the period of your function. Okay? And the period is the distance between any two sets of repeating points on the graph. Okay? So that could be like a max and a max, or a min to a min. So another way you can look at the period also is as the length of one complete cycle, or basically the length before the graph starts to repeat itself. So if you look at this function, and if I were to pick a point, the period would basically be the length that the graph would travel before it starts to repeat itself. Because what happens after this point right here? It's gonna go up and basically repeat itself. So this distance from here to here represents the period. Okay? You can also look at it as the distance from one max to another max, or one min to another min. No matter which one you look at, the purple curve, the distance between the two dots, or the distance between the two straight lines, the slashes, those distances are going to be the same. They're going to all have the same period no matter which set you look at. To find the period algebraically, though, it is 2 pi divided by the absolute value of b. And where do you think b is coming from?
That's the original function.
That original general form. And where's the b located in that general form? With the x in parentheses. And anything that's on the inside affects what? It's a horizontal type of transformation, but it affects the x coordinates. Okay? So it's going to affect the x coordinates of your sine and cosine curve. So to graph the functions that are in the form of sine bx and cosine bx, you're basically going to multiply all of your x values by 1 over b. Okay? Because if you recall, when we did transformations, whenever there was a number on the inside, it was always a horizontal stretch by the reciprocal, wasn't it?
Yeah.
So that's why we multiply all the x values by 1 over b. Okay? So we're going to look at this first one together. The second one you're going to do on your own. Cosine x over 3. Okay? It could be with parentheses or without. Still means the same thing.
Or 1/3.
B is 1/3. Because this original problem can be written like so. Because all we're doing is multiplying 1/3 by x. And 1/3 times x is just x/3. So we're going to multiply all of our x values by 3. Because it's always the reciprocal. Make sense? So this is cosine. So I'm going to write down my points. 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi 1. And actually, you guys do me a favor. Since you have space, please write those points not beside, because you're going to need that space. Write them below or above. Trust me, you're going to need that space. Or you can write over them, it doesn't matter. And you'll see why in just a second, why I'm asking you to do it below or above. If I ask you to find the period, you will use that formula of 2 pi over b. 2 pi over 1/3. Can I leave my answer like that?
No.
I'll have to do what?
Keep change flip.
Keep, change, and flip 1/3 and turn it into what?
3.
What's 2 pi times 3? So the period is now basically being stretched out all the way to 6 pi. So it's going to complete one full cycle in 6 pi radians. Normal cosine. Okay? Normal cosine goes from here to here, here, all the way up to here. What's that period? 2 pi. This particular one, cosine x/3, is now going to be stretched out. I'm basically going to take the end and I'm going to pull it
All the way to 6 pi.
all the way to 6 pi.
Ms. Anderson?
So we got to go all the way to 6 pi. And I know it's going to be a far stretch, but, you know, try to make it fit. That's why you needed the sides. Okay, that's why you need the sides. So all of my x's. No, they don't live in Texas. Are going to be multiplied by 3. So let's go ahead and multiply all my x's by 3. This one here of 0 is going to stay 0. But this one here at pi over 2 is going to turn into 3 pi over 2. Because when I multiply 3 times pi over 2, that just becomes 3 over 2. Pi times 3 is going to become 3 pi. 3 pi over 2, when I multiply that by 3, is going to become 9 pi over 2. And where's 9 pi over 2 located?
Just after 4 pi.
Just after 4 pi. Actually, right in between 4 and 5, right? Because 9 over 2 is 4.5. And then what's 2 pi times 3? 6 pi. So here are the points on my cosine x/3 graph. 3 pi over 2, 0. 3 pi negative 1. 9 pi over 2, 0, which is located right between 4 and 5. And then 6 pi 1. And as you see, it looks like I just took that end of my cosine curve and I just pulled it to the right. I stretched it out. So here we go. We have one complete cycle, okay? We can also do the same thing on the other side, okay? So did everybody get this down?
Yeah.
All right. So I'm just going to move it back over, okay? That point of cosine on this side, real fast. This point in negative pi over 2 is now going to be where? Negative 3 pi over 2. So just kind of extend your graph a little bit more to that point. and then you'll have a little bit more than a full cycle, okay? I want you to try the next one on your own. Change to a 2. It's gonna be 2. So sine 2x. Sine 2x. So since this is a sine function, sine crosses the y-axis at 0, 0. So my y's go 0, 1, 0, -1, and 0.
Yeah.
Okay? So this is our graph. Our original sine function, and it does have origin symmetry. So I'm just going to have it over that way. So unlike the last one, that the b was a fraction and it got longer, if it's a whole number, it's going to get skinnier, it's going to get smaller, it's going to be condensed. So I'm just going to push the two sides in together. So I'm going to end up multiplying all of my x's by what number? 1/2. So this becomes, stays 0, but this one becomes pi over 4. This one, pi over 2. This one, and the last one. Okay? So I'm at 0, 0. None of my y's changed. Pi over 4 is located where? Halfway in between. So I'm there. Pi over 2, 0. 3 pi over 4 is halfway. And then at pi. Yeah, you can definitely keep going because it's following the same pattern. So I go up halfway, then go back down, down halfway, go back up. And I can continue over here as well. This negative pi over 2, -1 is going to be where?
Between 0.
In between. This negative pi is going to be negative pi over 2. This one?
It's going to be up
In between negative pi and negative pi over 2. And this negative 2 pi. And it continues the same pattern on the other side. And as you see, it actually got a little tight. Questions about horizontal stretches? Or shrinks? Horizontal transformation. Now, horizontal transformations also affect the frequency of the function. And the frequency of a function is the number of cycles the function completes in a 1-unit interval. The frequency is the reciprocal of the period. And if you recall, the period formula was 2 pi over the absolute value of b. So the reciprocal of that would just be to flip it. The absolute value of b over 2 pi. And this is used a lot with like your word problems, such as like sine waves and things of that nature.
That's physics, basically.
Yes, pretty much. Physics is just applied math. So we're going to look at an example. It says musical notes are classified by the frequency. In the equal tempered scale, middle C has a frequency of 262 hertz. We're going to write an equation for a sine function that can be used to model the initial behavior of the sound wave associated with middle C, having an amplitude of 0.2. Now with any word problem, you read the function once and then you read it again and pull out important information. So musical notes are classified by frequency. What's important in that sentence? Frequency. And we just went over the formula for frequency, which is what?
Absolute value of b over 2 pi.
Next sentence says, in the equal tempered scale, middle C has a frequency of 262 hertz. What's important there?
262
Is the what?
frequency.
So that means I'm going to replace the word frequency with 262. Now the last sentence is the longest sentence, so I'm going to kind of split it up. It says, bless you, write an equation for a sine function that can be used to model the initial behavior. There's what I need to do. I need to write an equation for a sine function. In order to write an equation, I might need I'm gonna need sine, what else am I gonna need to write an equation?
X and Y. All
And where's that all coming from?
the general form.
The general form. I need the general form for a sine function. Okay? So to write an equation for sine, I need a general form. And then basically I want to plug in values for A, B, C, and D. X and Y stay where they are. Then the last part of the sentence says, of the sound wave associated with middle C having an amplitude of 0.2. What's important there? And what letter represents amplitude?
A.
So already I have y equals 0.2 sine. And I can actually find my b because over here on the left, I have an equation waiting for me that has my variable b in it, don't I?
Yeah.
How do I solve for b?
Multiply by 2 pi.
Because when I do that, it cancels out my 2 pi's. And before I go and typing it into my calculator, because I don't have one up here in front of me, I'm going to multiply 2 by 262. When I multiply 2 by 262, what number do I get?
524.
Okay? And I could leave it like this. I could leave my b in terms of pi. That's what this means. When I don't multiply the pi through, I'm leaving it in terms of pi. And this way I also don't have to worry about losing a rounding point because I don't round correctly. Because how should I round in this problem? Does it tell me how to round?
No. 3 significant.
So I should round 3 significant figures. So instead of having to worry about rounding 3 significant figures, why not leave it as exact?
Right.
So then all I have to do is plug in 524 pi x. Do I have any other information for C and D? And there's your answer. And the one thing, C and D can be the value of 0, but A and B can't. They're going to have to be a number other than 0. Because think about it, if A was 0, we wouldn't even have a function, a trig function at least. And then B is the same thing, okay? The sign of 0 is 0. So, C and D can be 0, but A and B would have to be some type of number, at least one. Questions on frequency? Back to graphing, real quick before the bell rings. A horizontal translation of a function is a phase shift. So moving from left to right is called a phase shift. And the phase shift is the difference between the horizontal position of a function and that of an otherwise similar function. So that's the whole moving left to right thing. As you see, the original light blue dotted line is being shifted over to the right to make the solid blue line. The formula for your phase shift is negative c over the absolute value of b. That's where the c comes in. You know, the c is right there inside of the parentheses with the x. Anything on the inside affects your x's. Okay? So then to find your phase, or to graph something with a phase shift, all you do is either add or subtract the c over b to all your x values. And these are your general forms, okay? So whatever c is, please make sure these are pluses too, by the way, because I think they're minuses in your notes.
Yeah.
Please make sure they're pluses. So whatever c is, whatever b is, you're going to plug in that formula of negative c over the absolute value of b, and then you'll, whatever that answer is, you'll either add or subtract it to all of your x's. Okay?
Wait, can you say that one more time?
So whatever negative c over b is, whatever that answer is, that's what goes in the circle, you're going to either add or subtract that from x. And you'll know whether to add or subtract if it's a positive number or if it's a negative number. If it's positive, you'll add, negative, you subtract.
Make sure you add
It only be negative.
No, because C is negative,
But the absolute value of b, what is
Make sure you
it?
have
Oh,
The b would be positive, the c was
So
negative.
just rewrite it.
So here's the example we're going to graph.
For both.
If you notice, the number out front, the a is 1, the b is 1. So there's no horizontal stretching or compressing and no vertical stretching or compressing because it's 1. Okay? But I am going to move my graph. So using my phase shift, the formula is negative c over b What is C?
What's the C? I,
Careful.
So C
C is a negative pi.
And close parentheses.
And B is the number in front of x, which is 1. Two negatives make a what? So I'm going to add pi to every single x value
From the side.
of my sine function. So I'm adding pi every time. What is 0 plus pi? What's pi over 2 plus pi?
3 pi over
3 pi over 2.
2.
So it's going to be a 3 pi over 2 plus pi, or 3 pi over 2, 1. What is pi plus pi? 2 pi. You're just adding pi to every x. What's 3 pi over 2 plus pi? 5 pi over 2. And what is 2 pi plus pi? 3 pi. So if we look, we're physically shifting the graph over to the right. Pi over 2 units. Where's 5 pi over 2 located? After 2 pi. And then before 3 pi. And there it is.
What's the second point? 2 pi over 2, right?
The second one is 3 pi over 2.
Oh, 3 pi?
Yes. This one's 2 pi, 5 pi over 2, and
So they don't connect.
not the original, not the black one to the red one.
No, but I'm talking about like the red, like when you know how we do the negative sign.
Oh, it was still the same thing.
Oh,
It's
it's all gonna shift. Oh.
yeah, it's all gonna shift over.
I
So,
think that the maintenance thing.
it's here there.